Alright, hello everyone, my name is Timothy Lee Grant, and I'm trying this new strategy of improving at Leetcode, which is, in the past, I don't really know what I was doing. I first started out by doing a whole bunch of random problems. That didn't help at all. I didn't improve. Okay. Then I decided that I was going to change up my strategy. Changed up my strategy multiple times, but I was focusing on, okay, I'm going to learn this concept, right? So I would go to a problem and just try to learn it, and really focus on concept. But, okay, I wasn't advancing very quickly, and I kept getting just bodied by mediums, and it wasn't working out very well. So, what I'm deciding to do now is, okay, what I'm going to try to do, I don't know if this is going to work, and this is kind of what I'm doing with these videos. It's almost an experiment to see if it's working. So, what I'm going to try to do is go and take a few problems, like 5 problems in each topic. So, I'm following, obviously, the Neatcode map. So this is how I'm kind of using the structure of, okay, concept, right? But then I'm going to, like right now, I'm doing 2 pointers and sliding window. Then I go on to the actual Leetcode, okay? And from this, I pick a couple problems, right? And I try to not necessarily memorize. That's not my point, is to memorize. At least I hope I'm not memorizing. If I'm doing my own strategy that I'm trying to implement correctly, I'm not just memorizing it. What I'm hoping to do is to pick like whatever 5 medium problems, and then just look at the problem, figure out like, okay, well, can I solve it really easily? If I can solve it really easily, okay, it's not really of interest to me. If I don't know how to solve it, not even attempt it. See, that was one of my problems in the past, is I would attempt it. I'm not even going to do that. I'm going right to a video, and I am trying to write down everything. So I have a little notebook, and I'm writing down all of the observations which I make, all of the stumbling points that I encounter. And so that's what I'm trying to do. Did it on, so I did my first time on 2 pointers, which was 2 weeks ago. And then last week, or this week, I did sliding window. So last Sunday, I did sliding window. And actually, I ended up stumbling on things that I feel almost embarrassed to even be stumbling on. So I feel like it makes me look like an idiot to even say what I was stumbling on, but that's kind of the point of these YouTube videos, is to document my actual progress, and that includes the stuff that I feel like, man, I really should know how to do this. Why is it causing me so much trouble? And it's something that's caused me a lot of trouble in with programming in general, and I've always hated arrays because of this. But it's those like off by one errors, and in specific, like with the sliding window thing, I would come into the case where, okay, well, I'm creating my so I go through all the problems, multiple problems, and then I kind of understand, like, hey, I get the idea. So we have a window, and we have to first get the window, and then we go through and ding, 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 like that, right? But what I was coming into was, I was thinking, like, it was so difficult for me to visualize, like, okay, well, is it up to k, or is it k plus 1? Is it k minus 1? Is it, okay, so k elements, right? And then I want to go over by 1, and then trying to figure out, okay, well, do I do the operation before I shift over, or do I do the operation after I shift over, right? Like, getting these kinds of, I want to say stupid. That's not the right word. Maybe basic. Basic is a better word in this case. Getting those like very, very basic concepts down, number one, obviously it is a little bit embarrassing that that's what's tripping me up, but it also helps that I'm writing all of my observations down and really trying to hone in on where I am coming into these issues. Because I think maybe in the past, maybe this actually might be one of my problems with Leetcode, is that in the past, I kind of brushed those basic things under the rug because I was too embarrassed to even confront them in the first place. But now, with this new method of like picking 5 problems and not moving on until I really understand those 5 problems, understand how it works, why it works, what's going on, and writing down everything, writing down all of my stumbling blocks, trying to find connections between these 5 problems, because I know, hey, these all 5 problems have sliding window. Okay, well, that gives me information about not the 5 problems, but I'm trying to abstract it out. That gives me information about sliding window, the abstraction. Oh, so okay, what kind of problems does sliding window solve? What kind of problems does sliding window allow me to work on, right? So that's kind of what I'm doing, and some of the, I guess, I'm having observations about the problems, right? I'm observing about the problems. I'm observing about the connection between the problems, but then I'm also almost meta observing my process of going about doing the Leetcode. So I'm trying to do all 3 observations at the same time. Today's video, what I'm going to do is, okay, I went over on Sunday how many problems are there? So 1, 2, 3, 4. So I went over 4 problems on Sunday, and I was as I mentioned, like I was expecting to do a little bit more than 4, but I just kept getting blocked, and I was trying to wrap my head around like these problems, and I just it wasn't clicking, and I just couldn't convince myself that yes, we should be moving over by 1 right now, or no, it should be up to k and not k plus 1. Like I couldn't convince myself that. And so I was really working on that. I didn't get a lot of problems, but what I'm going to be doing in this video is I'm going to be going back over those problems, the exact same problems that I did on Sunday, and seeing, okay, well, can I solve them now? I already went and reset them all. Okay, can I solve them now? Can I understand what's going on? And just making more observations. And again, this is unedited. This is, it might be the case where I'm able to get them. It might be the case that I completely fall on my face. So we are going to continue going through this Leetcoding journey, okay? And we're just exploring this part of the map right here. And that's all we're going to be doing right now, and we're trying to really get these problems. I'm doing 4 problems here. I did whatever, I think it was 5 problems on 2-pointer, and then maybe I don't know where I'm going to go. Either I go back up to 2-pointer and make sure that I still understand it. I also need to make I don't want to use the word meta because meta is about the process, right? But I need to make even more abstracted observations about, okay, well, I made abstract observations about sliding window. I made observations about 2-pointers. Okay, well, now try to group them together. Like, what do these 2 things have in common together? So that's kind of how I'm trying to do this process. So let's come here and let's do maximum or average subarray number 1. So I'm going to try to be doing this one, this one, this one, and this one. And so we'll see how far we go, how far we get. We'll see. Number 1, as I'm doing these problems, I'm going to be trying to make as many observations as I can. I'm going to be just going through and thinking about where I'm stumbling, what's happening, and see where we go from there. So let's take a sip of water and get going. All right, so you are given an integer array nums. Okay, so another thing about sliding window is, okay, well, what kind of problems does it operate on? Arrays. Okay, well, that's a nice observation. So if I see a problem, I know, like, hey, if it contains arrays, sliding window and two pointers are both methods that are possible ways that I can solve this question. Okay, now I need to make observations about, like, okay, well, what kind of problems, like, what does sliding window allow me to do? And I've already made the observation that sliding window is kind of like a subset of two pointers, right? It's just two pointers. You could move them this way, you can move them this way, you can move them like this way, you can move them this way, right? Well, sliding window is just two pointers, but moving this way, right? So I've already made that kind of observation. So now I'm trying to figure out, like, hey, well, with a sliding window, I'm given a problem. I see that it's arrays. Well, what kind of information does this sliding window allow me to do? That's one of the things. Okay, so you are given an integer array nums consisting of in elements. Okay, so in elements, so that's the total number of elements in this array, and an integer k. Find a continuous, right? Continuous, contiguous, never mind, array whose length is equal to k. Okay, subarray whose length is equal to k. So k is going to be a fixed number that has the maximum average value and return its value. Answer or any answer with a calculation error less than small number will be accepted. Okay, so I'm going to reread that question again to try to understand what's going on. So find a continuous subarray whose length is equal to, so there's going to be I'm going to have an array, and I'm going to need it to find a sub-array, so a smaller array within the big array. And this smaller array is going to be k units long, okay? And the information that I want, like the array, should be the maximum, like, average value. So I want to find the maximum average value. One of the observations that I can make with this is, because the average is the sum of the elements divided by the length of the elements, in this case, the length is actually fixed, right? So maximizing the average is actually the same thing as maximizing the sum. Because if you maximize the sum on a fixed interval, length interval, it's going to also maximize the sum, or the average. So that's one of the observations that I'm making. So I'm actually just trying to maximize the sum. And now the sliding window allows me to add up the numbers, and then here's a continuous array. So that's actually another really good observation to make. Okay, so sliding window gives me information on a continuous subarray, or like array within another array. So that's, if I see a problem, okay, And right now, I'm trying to explain it to myself, by the way. So if I see a problem and that problem is asking me to find something to do with a continuous subarray within a larger array, sliding window can help because it fundamentally does find a subarray within, or a continuous subarray within an array. Okay, that makes sense. That makes sense to me. Okay, so now what am I going to do? Well, I think what I'm going to do is I'm going to go through this array, and I know that it's going to be k units long, so I'm going to go find my window, which is k units long. Then I'm going to keep track of like current largest sum. Okay, I'm going to find the first window, which will be like the opening window. Okay, then what I'm going to do is I'm just going to go to my next loop, which is to iterate through. And when do I stop is when the right pointer, which is the leading pointer, okay, hits the end, bam, of the array. Because at that point, you've already found all of your continuous subarrays, right? Like you can't go over by one because now it's not even k units long. So, okay. And what we want to do is let's see, average value and return the value. So we're giving back the average, which if I have the sum, the largest sum, and I know the fixed length, I can just return the average. Okay, so let's do that. Let's go current large cur large, okay, is equal to what? It's equal to 0. So now what I'm going to do is I have this array, which is nums, okay? And I'm going to say, so I'm going to have length of num is equal to length of nums, okay? I'm going to say if length of num is less than k. Right, so now k stands for what? It's the number of elements that I want to find. Now again, I'm trying to purposefully say this stuff out loud because this is what I was meaning by off by one errors. So k is the number of elements I am trying to find. What does the ling operator do? It gives the number of elements in the array. So in the case that nums has k units, so I'm going to throw away this k because I don't want to abstract it. I want to take it to the particular. K is 5. So I want to find a continuous subarray of 5 units. Okay. So k is 5. Nums has 5 elements in it. So in that case, I want it to go and find those 5 elements, right? Goes to the end, it says that's the end, and it saves it, right? So I don't want to return if it's equal to. Okay, I only want to catch this if the length of num, if there are less elements, so this is elements and this is elements, if there's less elements in my array than how many elements I want to find in the array. Okay, so in this case, return 0. Okay. Now, I'm guessing one of the constraints is probably that there's enough elements, which right here it says k is larger than or equal to n. And notice I was right. Okay, cool. Because the equal to is a valid condition. So we got this right. All right, so now let's create our window. So we can do that. So I'm going to come here and I will have left is equal to 0, right is equal to 0. So I'm creating my left and right for 2 pointers. So right now they're at the same thing. I'm going to take my right and I'm going to move it over by k units. Okay, so while right is less than, and I'm going to say that because I'm not sure, I haven't convinced myself if it's equal to or not. What, k, right? I'm going to move it over by 1. But, and this is one of those things that I kept tripping myself over. Do I do the operation first and then increase, or do I increase and then? So what do we want? Right is at 0. I want to add that element to my sum. So I need to add, so current largest, actually, no, I need another one. Window plus equals nums of right. And then I'm going to have window is equal to 0. I'm just going to call this largest. Okay. So I am first going to add that number, the 0th element. I'm going to add it to my window. And then I'm going to go to the next one and add that one. Okay, so now what do I want to do? I want to go slide over by 1. So right plus equals 1. Okay. Now I want to keep doing this until my window has, I'm going to take another sip of water. Hold on a second. All right. So my window has k elements. That means I want to iterate through, and I think this is not going to be equal to the 0 or equal to the equal sign. And the reason is because this one is 0 indexed. So right starts off at 0. So I add the 0th element. Then I go to the next one. So at the time that right equals 1, I actually already have 1 element in it. So I don't want it to run again. Does that make sense? So let's say k equals 3. Okay. So, and right now my window is at 0. So I come here and it just begins. So k is 3 and right is at 0. So I'm going to come here, I'm going to add the first element, the 0th element, and now how many elements do I have? 1. Okay, then I move right over by 1. So now right is equal to 1. Okay, then I come up here, still valid, I add that element. So now I have 2 elements. I come down here, and now right is equal to 2. So I come back up here, and it's still valid. I add that element, so I add the 2th index, which is now the 3rd element. Right is equal to 3 now. So we're pointing to the 3th index, and I don't want to add that because I already have 3 elements in my window. Okay. So now, here's another thing that tripped me up. So now, left is pointing to 0, and right is pointing to 3. So I was thinking in my head, like, okay, well, these are... didn't I make the window too large? And now when I slide it over, it's going to be... it's already going to be too large. So... is that the case, right? Like, so I'm just going to write the condition. So while right is less than length of nums. We want to keep going, okay? And it's not equal to because right is a pointer, length of nums is the number of elements. Okay, so now I want, see, I know it's left plus equals 1, right plus equals 1. At least I think that's what it was from my memory. But now I've threw myself off because I said the thing about, wait, isn't it, didn't I make the window too big by 1 because I just threw off this one, right? Because I just added that. I'm gonna, hold on. So nums is equal to here, and I'm just gonna say 0, 1, 2, 3, 4, 5, 6, 7. And I want my, I'm going to say k equals to 3, okay? So as of right now, left and right are here, are both at 0, and I haven't added anything yet. So I come here. So obviously this is left, this is right. Okay, so I come here and I add this to my window. So now it's like this, okay? Then I come here and I move right over by 1. Okay. Then I come here and it's still valid because right is now pointed at 1. So then I add it. Okay. And I increase it by 1. Okay. Still valid up here because this is now pointed to 2. So now I add it, right? Hold on, I add it, okay. And now I've added 3 elements, okay. Then I come here and I do that. I move it over by 1. Okay. See, but if I do this, I'm doing like I'm doing something like this. I do left, I come here, it's like that, right? And then I do right. And notice I'm doing right plus equals 1. And this is additions, right? I'm just going to abstract it. Okay, whatever. But now right, I never did 3. I just directly goes there, so I never captured that 3. Am I misremembering something? Let me just write this out and see if I've got it. Because if this solution passes, I haven't convinced myself. This is what I'm meaning by those off by 1 things. See, this is exactly what I'm meaning. So I'm going to try to write it the way that I remember it being correct. And then if it actually is correct, that means that I don't understand it. So it's kind of a funny thing, like, oh, you got it right, therefore you don't understand it. But that's why we try to make observations. Okay, so if, and then I think I do need to save the current window. So largest is equal to window, right? Because I just realized if there's negative numbers that I can't just automatically assume that window is actually going to be larger than 0. That means largest, I just need to change it to, how do you do it? Like negative, float infinity, I think it is. Okay, so now what I do... oh no, I could have just set it to window. I'm kind of... It's not important. Okay, so now what I can do is I can just say largest is equal to max of... and I need to actually change current window. So window is equal to minus equals nums of left. So we're kicking out left. Window plus equals nums of right. Okay. And now we do the largest is the maximum of either the max that we already have or the window that we just calculated. Okay, so we do that until we hit the bounds, and then we return the largest divided by the number of elements, k. And k is an integer, so I do float of k. All right, so yeah, I subtract out that element here. So now it's left is there. Or is it left minus 1, right? So I just moved left over by 1. Because in this case, I just subtracted that one. I think it has to be the other way around. So okay. So what I'm saying right now is I think that actually just by my little graph up here, it has to be that window that you do your additions and subtractions above when you do your shifting. It just doesn't... Oof, okay. And then I can do the finding the largest after, like it can either be here or here, it doesn't matter. But as long as because it's only dependent on window and largest. This feels right. Or not feels right, but I mean, according to what I did up here, like okay, let's see. Of num. Okay. Come on, come on, come on, come on. Okay, so it was right. Okay, it was right. So, code. Okay, so yeah. It is like this. And so, how did I do that? How did I do it? Okay, so come here and I create my window. So it's like this, and it comes here. So it's like this, and then I take it and I move it here, just right there, and then I move it over by one, which is right here, and then I do it again up here, so I add it, and move it over by one, right? Come up here, I add it, and move it over by one. Move it over by one, right? So then there's 3 elements here. There's 3 elements in my window. Then what I do is I come here and I subtract out this element, because right now my left is pointed to 0. So I subtract that out like that. Oops. Like that. Okay. I subtract it out, and then I add this element. Okay, and now notice there's there's 3 elements here, but it's a new window, right? Okay, and then I can move them to the next index. And notice I will not get an index outside the bounds of the array, because let's pretend like I chopped this off, right? Let's pretend that I chopped this off. So I'm at the end of the index, like this. And I just came here, and now left is increased by 1. Okay? And right is increased by 1. Like that. I find the largest, and then I come here, it's outside the bounds, and then I just return. Okay. Cool. So let's move on to the next one and keep making observations. So this one is longest substring with at least k repeating characters. Okay. Another sip of water. All right. Given a string S, and remember, strings are just character arrays, so they are just arrays of type character, okay? And an integer k, return the length of the longest substring such that the frequency of each character in the substring is greater than or equal to k. Ooh, okay, I did this problem, but now when I'm going back over it, I don't even know what that means. Okay. Let's look at the examples and see what's up. So the longest Okay, so okay, I kind of remember what's going on with this. This one was asking, like, you're given a string and k is the we want to find a string that has like that many, like, k number of repeating characters in it. So like so k is 2, so a is 1. Now a is 1, b is 1, a is 2, b is 1, so it's still not a valid substring because b is only at 1. But now A is 2, which is valid. B is 2, which is valid. So this is a valid one right here, and it's 4 units long. Now B is 3, A is 2. So that's still valid, and it's larger. So this is a larger window. And then C is added to the mix, and it is now not valid because C only appears once. So, man, how did I... The longest substring is... How does a window help me here? And how am I moving it? That's the other question. It's like, how do I move it such that... Because it seems like it's more of a jaggered movement or something, not a smooth sliding, which, at least from my understanding, is not what sliding window is actually about. Sliding window, you have a fixed window which you are sliding it over. I mean, the stupid way of doing it would just be, okay, I create a window of size 1 and slide it over. Is there a valid substring? Yes or no? Then I go to 2 and slide it all the way over. Is there a valid substring? Yes or no? I go to a window of 3, slide it over. Is there a valid substring? 4, slide it over. Is there a valid substring? Length of the array. Is it a valid substring? But obviously that is a horrible time complexity. So anyways, I can't immediately think of the solution here. I'm just going to go directly to the solution, and I am going to go to the one that I did last time. How do I see my code? Here it is. So what am I doing? This solution works from GPT, but I have no idea what it is doing. Oh, okay, well. No wonder I couldn't figure it out now. So frequency is... a dictionary. Left and right are here. Well, left is... So I'm ending when right is at the end, okay? Frequency of S of right equals frequency of... This is that really stupid one. Okay, this is the really stupid one. I'm not doing this one. No. No. So I wasted so much time on this. I wasted so much time on Sunday over this problem. I didn't get anywhere. I couldn't understand it. I spent so much mental energy on this problem. No. We are learning here. We're trying to learn, not trying to do some... I think this one has some weird trick in it. Okay. No, you're going away. Right away. We're not doing you. Okay. 209. Minimum size subarray. And by the way, this is what I'm meaning by my strategy of Leetcode is right now is I'm not trying to do hard problems. I'm not trying to find those really weird like tricks. I'm trying to understand the concept, right? And I'm trying to understand the fundamentals. I'm trying to understand where I'm getting problems. If I find some weird problem that has some trick in it or is a very strange problem, I went online and I think that's the one that also didn't have very many what was the one that I just said? With K repeating, right? Was it this one? Without repeating. Anyways, I never mind. But I'm not trying to go and find some. I don't want tricks. I want to understand the basics. Um. So, anyways, given an array of positive integers nums and a positive integer target, return the minimum length of a subarray whose sum is greater than or equal to target. If there's no subarray, return 0. So subarray, again, is a continuous array within a larger array. Okay, so I'm just making a note that, okay, the sliding window, once again, I have another problem that is an array within an array, which it needs to be continuous. Okay. So given an array of positive integers nums and a positive integer target, okay, whose sum is greater than or equal to the target. Okay, so target is 7. So the subarray 4, 3 here has the minimum length under the problem constraint. So 4 plus 3, 7. So that means that it's valid. Okay. So maybe I can come here to create my window and stop once it gets to 7. So 5, 6, 7, 8. So I have a window here. And then can I boot off the smallest number? Maybe I can take away my left until it's no longer valid anymore. So right now I have 8, 7, 6 right here. So now it's invalid. Okay. Then I can come and have this. So I add this number and it's valid again. So then I subtract 3. Okay. And so 4, 5, 6, 7. So this is valid now. So then I try to subtract this one. And this is invalid. So then I move my right pointer over by 1. And this is valid now. And so I move my left over. Okay. This is valid. So I try to move my left over here. And this is invalid. So I try to move my right over by 1. And that's when I stop. Okay, so let's see. Longest is equal to 0. So right is equal to left, which is equal to 0. So we're setting our left and right to 0. Current sum is equal to 0. So now I'm going to go and try to create my window. So while what? So I don't even know if this is working, but if it does, this seems like it's not a smooth slide either. It's more of a jagged slide. Okay. What do I want to do? I want to, while right is less than length of n, or is it nums? Nums, okay. Nums. Length of nums is equal to length of nums, okay. Well, this is the case. What do I want to do? I want to keep increasing my right pointer until, so first I need to actually add the element, right? So current sum plus equals nums at right. So I add that number in there. Then what I want to do is I want to check if it's valid. Okay. So if current sum is larger than or equal to the target, I want to check my current window, right? The length of my current window. Yes. Longest is equal to the minimum of, actually this should be shortest. Shortest and the current length of the window, which is what? Right minus left plus 1. Okay. So now what I want to do is I actually want, this should be a while loop. So while this is valid, I want to keep moving my left over by 1. So current sum minus equals I'm booting off the left pointer one. So nums at left, and then I move my left over by 1. Left plus equals 1. So I move my left over. So I boot the array out, or I boot the element out, and then I move my left over by 1. Okay, so I want this to keep going until current sum is smaller than the target. Okay. So then what do I want to do? Well, now it's invalid, so I need to move my right over by 1. So right plus equals 1. Okay. Return shortest. Is it gonna work? Oh. Come on, come on. Why did that not work? Oh, is going to be equal to sum of nums plus 1. So this is going to be like invalid. So we want a big number, right? I could do infinity. Actually, maybe that would be more time efficient because this is O of n, right? And there's, I guess, not a hit to it because I'm already doing O of n operations here, but I don't want to do O of n plus O of n, even though O of n plus O of n equals O of n. But anyways, I can just do like float infinity. Okay. Let's make sure that we got, come on. Infinity. Yeah. I see the problem here. Return shortest. So what would it be? Like return 0 if shortest is equal to because right now what it's doing is it's saying, oh, okay, well, if there is no valid solution, it's just going to return the shortest with it, which is infinity. That's not what I want. I want return 0 if there's nothing. Okay. Here, else return shortest. So little tricks I'm not worried about. I want the algorithm. I want the basics. I want the understanding. Okay. Worked. Submit. Please, please, please work. Okay. Okay. We're going to go to the next one. It's almost 1 a.m. But we're going to try to do this one too. And let's go. All right, 187 repeated DNA sequences. The DNA sequence is comprised of letters, 4 letters. And so it can be something like this with each of the characters being one of those 4 letters. Okay. When studying DNA, it's useful to find repeated letters within the DNA. Okay. Again, repeat. So I'm concerned about a subarray within a larger array. And I'm also seeing return all 10-letter long sequences, substrings that occur more than once in the DNA molecule. Okay, so substring within a larger string of a fixed size. I'm starting to see a pattern, and that's the exact thing that I'm talking about when I say I want to be picking a couple problems, like I think 5 is a good number, of a given domain, whatever it is, 2 pointers, sliding windows, of a given domain that I'm able to see the commonalities between those 5 problems. Understand, like, okay, well, I see 5 specific problems, try to abstract it out to the generalized. Okay. Let's go. So, I remember doing this. I come here and I'm like, ding, 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 ding. I do 10. Okay, so I create my window again. And now what I want to do is I want to add this, right? I want something that I can put this window into, slide it over by 1, and check, like, is this repeated? So I want to add, fundamentally, I want to add in elements into a set or a dictionary, right? And so next, so I'm going to add this into a dictionary and say, is it already in there? Yes or no? If no, well, then it's not repeated yet. Then I'm going to come here and do this and say, is this already in my set of scene elements? Yes or no? If no, okay, well, I haven't seen it before. So I'm going to add it to scene and then move to the next one. Sliding window, right? Okay, so come here and then I come here. Is this in scene? No? So I add it and move on. Then eventually I'm going to keep sliding over and I'm going to get to the point where I go here and I'm going to try to say, like, is this in scene? Yes or no? And then all of a sudden I'm going to say, yes, it is. It's already in my set. Okay. So another observation that I'm making right now is sets are a nice way of being able to add windows to be able to see, like, hey, have I already seen something like this before? Okay, so let's do this. Scene is equal to set. Okay. So now I need to create my window. So while left equals right equals 0, while what? While right is less than S? What was S? Oh, 10. It's fixed at 10. 10. Okay. And we already know it's not equal to, so we've already done this. I want to add the current element of S. So I want to come here, I want to add an A. Then I want to add another A. Then I want to add another A. So I want to go like this. Word plus equals S of right. And then right plus equals 1. And now, by the way, if people are telling me, hey, you can do word is equal to S sliced at something, I know I can. I'm trying to focus on, like, trying to find a concept that I can understand, right? I'm trying to just I know, like, this helps me understand, like, building my window. Okay. Then I know that I do need to also learn how to do this, but right now I'm trying to learn how to build my window and then how to slide it over, how that applies to the problem, how to connect, like, okay, well, this particular problem with the broader problem, and then that broader, or the broader topic, and then that broader topic with the other topics, right? So, okay. Now, what I should do, I have a window, a valid window. So I've just done this. What I want to do now is I want to add that to my set. So scene dot add what? That word. Okay. Now I want to keep going. I want to keep sliding my window over by 1 unit each time until my right gets out of bounds. Okay, so while right is less than length of S. Okay. Length of S is equal to length of S. what do I want to do? Okay. I want to I want to kick this one and add this one. Okay, so word, and I think I will have to use slicing here. Word equals s sliced at what? Left, and I don't want to include left. Plus 1. Now I need to figure out, does this cause some kind of like boundary condition ever? Like what if S doesn't exist? Like the substring doesn't exist. S is 0. Left is now equal to 0. It comes here. I mean, if we don't even have 10 in here, then there's never going to be a repeated thing. So I can come here. If length of S is less than 10, return an empty element. Empty list. Okay, so now I know that this is not going to be out of bounds yet. Yes, because left is always going to be 10 elements. Okay, so there's always going to be a buffer of 10, so that's fine. Okay. Now I'm just making a note in my head like, okay, but I can't guarantee that in other problems. I can't try to abstract that out. That's specific to this problem because there's 10 elements here. My window is 10. Okay. So I kicked that one. And, oops. And now I do what? I want to do right. I want to add the right element. And that is going to be, because this, when doing slicing, the last element is non-inclusive, and I do want to include it. So it's going to be one element over. So it's currently my right is pointed here, and I want to add this element. So I actually like bump it over by 1. So plus 1. And now, like, let's say that my right is here, and I bump it over by 1. It's technically outside the bounds, but it doesn't include that when you're doing slicing. So actually, it just grabs that one. So I think that should be correct. I'm not exactly sure. But now I have a new word, supposedly, that bumped the last one over and added the next letter over. Okay, so now I want to check, is it in scene? So if word in scene, then what do I want to do? I want to add it to my answers list. Here's another trick that I figured, or not I figured out, but I made note of when I was doing this problem on Sunday. A nice way, because we actually want this list to be unique. Well, lists by themselves are not fundamentally unique. You can have a list of 1, 1, 1, 1, 1, 3, 1, 1, 1, 1, 1, right? So you can have repeated elements in a list. Sets are unique. Each element in a set is unique. Okay. So what that means is you can actually build a set and then at the very end convert it to a list, which guarantees you can add. I add 1 in it. I add 1, add 1, add 1, add 1, add 1, add 1. And then at the very end you say, okay, take that list or take that set, turn it into a list, you're going to get a list of one element containing number 1. Okay, so result.add word. So I want to add word to my result. So result is going to be equal to a set. So I want to add word to my result because I've already seen it once. I know it's repeated. Okay. So I keep doing that until I hit the end. So now I should be able to do return list of result. Come on. Oh, okay. We're not done yet. Okay. Word equals like that. Let's see. Come on. I don't like that it's taking a long time. Oh, we didn't increase right here. Okay, stop. Yeah. So now we have to increase right. And we need to increase left. Okay. Well, I mean, yeah, because I didn't... Obviously, I need to add scene.add. Each time I slide the window over by 1, I need to actually add that word into my set. Okay. There we go. Okay, cool. So fundamentally, I think I was able to conceptualize it and get it. All right. So another thing of that, while I'm doing these YouTube videos, I'm really trying to experiment with is, okay, am I just memorizing it? Was I able to do these problems because I've memorized it and I kind of knew where I was going, right? I just needed my memory jogged a little bit, right? I'm trying to figure out, okay, am I actually understanding it, or am I able to make abstractions? Am I getting better at the topic? Am I understanding the topic better? That's something that I'm playing with. I'm trying to do experiments with. And going forward, the more I do this, the better picture I'm going to be able to get. Like, is it actually abstracting? Am I improving? And I'm going to be documenting the entire process and trying to make as many observations as possible. So if that's something you're interested in, you're curious about, you can subscribe to this channel. And yeah, hopefully these videos are helpful. Not sure, but yeah, if that's something you're interested in, you can definitely subscribe, and I will be documenting my entire process, both with Leetcode and also doing projects to try to become a back-end software engineer. So yeah, have a wonderful rest of the day. My name is Timothy Lee Grant, and I will see you guys in the next video.